Good morning, students. So now you are in your third chapter, that is matrices. Till now you have studied about the introduction part, definition of a matrix, types of matrix, what is order, what are the elements, how you can write a matrix, different types of matrices you have learned, and then you learned about operations of matrices, that is addition, subtraction, and multiplication. Multiplication are of two types, that is scalar multiplication and matrix multiplication. So I hope till that portion it is very clear. Moving on to the next topic, that is a transpose of matrix. And in transpose of a matrix, you have a definition. Actually, it is very simple. Transpose, you have to just interchange row and column. In question, there will be matrix, you have to just interchange row and column. I'll tell you the definition. If A is an m cross n matrix, then the matrix obtained by interchanging its row and column is called the transpose of the matrix A and is of order n cross m. So here row will be changed to m, row will be changed to n, and n column will be changed to m rows. Okay, m cross n will be the order of a matrix. When you take the transpose of a matrix, that will be n cross m. If A is equal to Aij and order is m cross n, then A dash is equal to A dash. A dash is denoted as transpose of a matrix, or else you can denote it as A power t. Okay, so here A dash will be having order n cross m, or A power t will be having order n cross m. So here Aij is now changed to Aji. That is, row is interchanged to column. I have given few example. It is matrix and transpose of the matrix. Here A is 1, 2, 6 and A dash. This one row, 1, 2, 3, 3 column is now interchanged. This row is interchanged to column, that is 1, 2, 6 is in row, that is interchanged to one column. Always the first entry of a matrix of A and A dash will be same. Here it is 1, again A transpose, it is 1. So here the order is 1 row and 3 column, 1 by 3 matrix. Here it is 3 rows and 1 column. So the matrix order is 3 by 1. Okay, it is 1 by 3 matrix and here it is 3 by 1. The next matrix B, you have matrix 5, 9, 0, B dash or B transpose. In this you are having 3 rows and 1 column. So this 3 row is changed to 1 row, 5, 9, 0. Here you are having only 1 column, but in B transpose you are having 1, 2, 3, 3 column. So the order of the matrix of B transpose is 1 by 3. Similarly, the matrix C, you are having 2 by 2 matrix, that is 2, 3 is your first row, that is changed, C dash, it is changed to first column. Second row, 0 and 8, it is changed to second column. So here 2 row 2 column, again here also it is 2 row and 2 column. So C and C dash, row and columns are interchanged. See the question, first question, consider A is equal to matrix 1 4 1 2, find A plus A dash. In this question you have to find A dash. A, it is already given in the question. You have to add this A dash, A transpose and this A and find the answer. So here A dash, you have to interchange row and column. 1 4 is your first row, that is interchanged to first column 1 4. Second row 1 2 is interchanged to second column 1 2. Again you have to, according to the question, you have to add these two matrix, that is A plus A dash is equal to 1 4 1 2 plus matrix 1 1 4 2. So here addition of the matrix is taken place. 1 plus 1 it is 2, 4 plus 1 is 5, 1 plus 4 is 5 and 2 plus 2 is 4. So here you got the matrix as 2 5 5 and 4. So that is the answer for this question. In the next question, if A is equal to matrix 2 3 1 4 1 2 and matrix B is equal to 1 minus 2 1 1 2 1, you have to find AB. AB means you have to multiply A and B matrix. You will get an answer for that. And then you have to find AB whole transpose. You have bracket along with AB. So that means the answer what you are getting for AB, you have to take transpose of that matrix. In the second question you are having, verify that AB whole transpose, that is equal to B transpose into A transpose. That means in A question you got the answer for AB whole transpose. So LHS answer you will be getting from the first question. And then you have to find, this is AB you are multiplying, then finding the transpose here. But here in this case you have to find separate B transpose, separate A transpose, then those matrix, two matrix you have to multiply and you have to check whether this answer and this answer is equal. So to begin with the answer, you have to see what is AB. You have AB, sorry, you have A and you have B matrix. Multiply. I think you all of you know how to multiply two matrix. So it is 2 into 1. I'll just brief up the multiplication. 2 into 1, 3 into 1, 1 into 2. You have to add all these three. That is 2 plus 3 plus 2. Next it is first row, second column. That is 2 into minus 2, 3 into 1 and 1 into 1. You have to add. Then it is second row, first column. Then it is second row, second column. I have written the entries here. You just go through it. And the final answer what you are getting is 7 7 0 9 minus 5. So the matrix is 7 0 9 and minus 5. Now you have to take transpose of this matrix. That is AB whole transpose is equal to 7 0 9 minus 5 whole transpose. First you will be writing what is AB matrix. In the power you have to write T or dash. That is equal to, how will you write AB whole transpose? The first row is your first column. So 7 0 will be writing 1 by 1. Then 9 minus 5 is here. Second row is changed to second column. So you got the answer for AB whole transpose. The next question, you have to find the multiplication of B transpose into A transpose. So here A transpose is, you will write what is A, 2 3 1 4 1 2, and the whole transpose. So that is, this first row will be changed to first column, second row will be changed to second column. Similarly, you have to write what is B transpose. After that, you have to multiply B transpose and A transpose and check finally check whether the answer is same. You got here the answer as 7 9 0 and -5. So I think LHS and RHS, you got the same answer, that is 7 9 0 and -5. So this is the answer for this question. So then you can write, hence AB whole transpose is equal to B transpose A transpose. Next topic is symmetric and skew symmetric matrices. This is one of the important topic in this chapter. So symmetric matrix, you have to remember the formula A transpose is equal to A, or A dash is equal to A. Skew symmetric matrix, you have to remember the formula A dash is equal to minus A. So LHS and RHS matrix should be equal in both the condition. So here I have the matrix A as 2 1. So we have 2 1 3 1 4 5 and 3 5 6. So you have to find A transpose. I think by now you know how to find A transpose. A row is changed to column 2 1 3. This row is changed to this column 2 1 3. 1 4 5 1 4 5. 3 5 6 is changed to third column 3 5 6. After that you have to check whether this A answer, A question, what is given in the A matrix, what is given in the question, and A transpose, these have same entries. If you see the screen, you can see that the entries of both the matrix are equal. So here A dash is equal to A, it's a symmetric matrix. Similarly, for A skew symmetric matrix, the condition is A dash is equal to minus A. So you have matrix A, then you have to find A transpose, that is row is interchanged 0 2 minus 3. That is interchanged to column, first column 0 2 minus 3. After finding A dash, the condition is A dash is equal to minus A. So then you put equal to sign and then write this minus sign as it is. After that, write the question, that is the matrix A, what is given, write as it is, don't change anything. 0 2 minus 3 minus 2 0 4 3 minus 4 and 0. You just have to write the question, and then after that please check A dash and minus A. See here, negative sign is outside the bracket. 0 into minus, that is always 0 only, no sign is needed for 0, so it is 0. And negative of 2 is minus 2. Inside this square bracket there is minus 2, that is of A dash. Here negative is taken outside, still these two entries are same. Now here minus of minus, it is plus. You can see here that this 3 is positive. And the next row you have negative of negative 2, that is positive 0 0, and then negative of 4 is negative 4, and then negative of 3 is negative 3. Negative of negative is always positive, so you are having positive 4, then it is 0 0. So you can see that whether it is this matrix or this matrix, all the entries are same. So A dash is equal to minus of A, so it is a skew symmetric matrix. This is how you have to find the answer for symmetric matrix and skew symmetric matrix. Next, you are having a note, small note. It says that elements in the main diagonal of a skew symmetric matrix are all 0. You know what is a main diagonal? I had taught you. I have taught you about main diagonal. So in skew symmetric matrix, main diagonal elements all will be 0. A matrix which is both symmetric as well as skew symmetric is a 0 matrix. When you're considering a matrix, if it is both symmetric and skew symmetric matrix, it will be of a 0 matrix. In 0 matrix, all the entries will be 0. I have given a question to solve for you people. So see the question. It is, show that you have matrix A is a symmetric matrix. So I have given a question to show that it is the matrix, this matrix should be a symmetric matrix. How will you solve this question? First of all, you have to write what is the condition of symmetric matrix. The condition is A dash or A transpose is equal to A. So for this A matrix, you have to find A transpose. After finding A transpose, you have to check the matrix what you have got and the question and see whether the corresponding elements are equal or not. Okay. I have just written the condition, that is formula. You have to write accordingly. Similarly, for the next question, you are given a matrix A and you should show that it is a skew symmetric matrix. Here also I have written the formula A dash is equal to minus A. So here in this slide I have shown how to find a skew symmetric matrix. So similarly, you have to find answer for this question. First find A transpose, then write minus A, write minus sign and write this A matrix as it is and check whether A transpose and minus A is equal. You have to do it by yourself. And the next question you are having, find the values of A and B. In this question, you have to find what is the value of A and B. And the matrix is given 0, 3, A, B, 0, minus 2, 5, 2 and 0 is skew symmetric. Already it is given that this matrix is skew symmetric. So there is no name given for this matrix. So you can take it as A, this matrix as A, and write what are the entries in this matrix. If it is skew symmetric matrix, which condition should be satisfied? You have to know the condition for skew symmetric, that is A dash is equal to minus A. So you have the matrix A, you have to find A dash and then you have to check for minus A. Okay, minus A. How will you write minus A? How will you write for minus A? If it is minus of A, I'll write it here. You just have to write minus, then write this matrix 0, 3, A, B, 0, minus 2, 5, 2, 0. And just check whether this minus A matrix and this A dash is equal. Okay, so here you can find that can find that this B, can you see this B over here? This B is your entry in this minus A. So here 0B5, in A dash it is 03A. So here minus of B is equal to this 3. Okay, or if you see this first row, this B is equal to this 3 corresponding element in first row of 2 matrix minus A and A dash. So here you have the value for B as 3, but for this 3 there is a negative sign over here because it is minus A. So the answer for B is minus 3. Okay, similarly for A, see here A, you have the answer as 5, but this 5 carries a negative sign. So this A is equal to minus 5 is your answer. So here it is written B equal to minus 3 and A is equal to minus 5. So to know this, to know how to solve this, you should know the condition first. Then you have to compare the elements of 2 matrices. You have theorem that is important to solve the next section. So till now you know to solve symmetric matrix and skew symmetric matrix. In the next section you will be having sum of symmetric and skew symmetric. So for that there is another formula which will be applied in solving the question. So for that you have to know what are these theorem. So in the first theorem it is given that for any square matrix A with real number entries, A plus A dash is a symmetric matrix. So when you add A and A transpose, that matrix will be symmetric, and when you subtract A and A transpose, that matrix will be skew symmetric matrix. In the theorem 2 it says that any square matrix can be expressed as sum of symmetric matrix and skew symmetric matrix. This theorem 2, based on this theorem, almost all the question paper it is asked from previous year question paper. Almost all the question paper has question based on this theorem, and it is very important. Only if it is asked sum of symmetric and skew symmetric matrix. If it is sum, you have another formula. That is, I'll tell you step by step how to solve the question. Nothing much difficult in that. Just you have to know how to add 2 matrix, how to find transpose of the matrix, and how to find the difference of 2 matrix. So here for the matrix A, matrix 2, 4, 5, 6, verify that A plus A dash is a symmetric matrix. So here you are given a matrix A, you have to verify A plus A dash is a symmetric matrix. So here I had told you about symmetric matrix in the previous slide. That is A dash is equal to A. But here you are having A plus A dash. So this is 2 matrix, adding 2 matrix. So this I'll take it for simplification. To make the simplification purpose easier, I'll take this as P. Okay, this I'll take it as P. This A plus A dash, I'll take it as P. Then after finding P, that is your A plus A dash, to know whether this is symmetric or not, you have to find P dash. A is equal to A dash, that is a condition. Here it should be P is equal to P dash. So here P is your A plus A dash. So P dash. So you have to put the bracket and to the power dash. So this much you have to find. Okay. First you are having A matrix 2, 4, 5, 6. You have to find the matrix A dash, A transpose. That is first row is your first column. Second row is your second column. Then you have to add these two matrices as per the question. As per the question, you have to add these two matrices. So here A plus A dash, you got the answer as matrix 4, 9, 9 and 12. That now you have to take it as P. And then to know whether it is symmetric or not, you have to find P dash. How will you find P dash? This P matrix, you have to interchange row and column. So this first row 4 and 9 will be your first column, and this second row 9 and 12 will be your second column. And then you have to check whether these two matrices are equal. So this is equal, right? When you see the screen, you can see that corresponding element of P and P dash are equal. So you can say that this matrix is symmetric. Similarly, you have the question matrix A 1, 5, 6, 9. You have to verify A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. So symmetric matrix, as I explained to the previous question, by seeing the slide, I think you can make out how to write the answer for this A question. I'll move on to the B question, that is A minus A dash. For A plus A dash, I have taken as P, right? For symmetric, I have taken as P. Here I'll take it as Q. That is for A minus A dash, I'll take as Q. So you have to find the difference between these two matrices, that is A and A dash. You will get an answer. That answer you have to mark it as Q. And then you have to find Q dash. Q dash is your transpose of this Q. That is A minus A dash whole transpose. That is your Q dash. You know that skew symmetric matrix, the condition is A dash is equal to minus A. In this case, how it will be? It will be changed to Q dash is equal to minus Q. So then you have to check whether these two matrix entries are same. So here you are having 0, 1 and here minus 1, 0. Here negative sign outside, 0, minus 1, 1 and 0. If you check these two matrices, you can see that these two matrices are equal. So it is a skew symmetric matrix. Next, here I have given 4 steps, that is steps to find sum of symmetric and skew symmetric matrix. These steps should be used only when the question is asked for sum, SVM. You have to read the question carefully, not for only symmetric and skew symmetric. For that you have to use this formula. Okay, here what I have given, dash is equal to A for symmetric and A dash is equal to minus A for skew symmetric. But if the question is sum of symmetric and skew symmetric, you have to write step by step answer and the steps are given here. First you have to find P. In this case P is addition of two matrix and multiplying that with 1 by 2, half. Or else you can directly divide all the entries by 2 because division of matrix is not there. So you have to just multiply by 1 by 2 or you have to divide all the entries by 2. And this is a condition for symmetric in sum of symmetric and skew symmetric matrix. And here in the next step, this is the first step, and the second step, after finding P you have to find Q, and this is for skew symmetric. In this you have to find difference between two matrix and then you have to multiply by 1 by 2. And after getting these two matrix you have to add P and Q, that is you have to find the sum of P and Q. And the interesting part is you can check the answer by yourself whether you did the your method is correct, if you get the right answer or not, for getting the right answer or not. So for that final answer should be the question itself. So when you add these two matrix you will get the answer as question itself. So you can be very sure about the answer. So here see the question, express the following matrices as sum of symmetric and skew symmetric matrix. So here the question is sum of symmetric and skew symmetric matrix. You have the question matrix 3, 5, 1 and -1. The first step you have to find P. So how will you find P? P is A plus A dash. So first you have to find A dash, then add with A, then multiply with 1 by 2. So for that I have written A, found out A dash, you have to add A plus A dash, you will get one answer. Then you have to multiply this matrix what you are getting by 1 by 2. So here you got the matrix as 6, 6, 6 minus 2, that is multiplied by 1 by 2. So that is 1 by 2 into 6, that is 6 by 2. 6 by 2 is your 3, and then 1 by 2 into 6, that is also 3. 1 by 2 into 6, again 3. 1 by 2 into -2, -2 by 2 is always -1. So you got the answer for P as 3, 3, 3 minus 1. If you want you can write this step also, that is the condition of symmetric matrix. What is it? P dash is equal to P. Then next line you can write P is equal to half into A plus A dash is a symmetric matrix. So by this you got the answer for P. Similarly you have to solve it for Q also. So Q it is half into A minus A dash. You can do it separately also or together also. I have done it together. You have tried half and write what is A minus A dash. You have tried two matrix and you have to subtract. After subtracting you will get the answer as 0, 4 minus 4, 0. You have to multiply that with half. 0 by 2 is, however it is 0, and 4 by 1 minus 2 it is 2, minus 4 by 2 is again minus 2, 0 by 2 is 0. So here you can check Q dash is equal to minus Q, that is the condition for skew symmetric matrix. After that you have to write Q is equal to half into A minus A dash is a skew symmetric matrix. This is your second step. After finding P and Q, the third step, what is the third step? That is you have to add the answer of P and Q, that is P plus Q. You'll write the matrix P, you'll write the matrix Q, you'll add. I think all of you know how to add. 3 plus 0, 3 plus 2, 3 plus minus 2 and minus 1 plus 0. Here you will be getting the answer for P plus Q, that is 3, 5, 1 and minus 1. And this you have to check with your question. See here 3, 5, 1 minus 1. So you can be sure about the answer. So here you got the correct answer following these three steps. That is, you got the answer as A itself. Then you can write, thus A can be represented as sum of symmetric and skew symmetric matrix. So this is how you have to solve the question of sum of symmetric and skew symmetric matrix. I'll repeat if you're not understood. I'll repeat the steps. Okay. This is, you have to find A dash, then add with A, multiply with 1 by 2. That is your P matrix. Then you have to find Q. Subtract A and A dash, multiply with 1 by 2. You will get one matrix. That is your Q. Then you have to add P and Q. That is your sum. And then final answer should be the question. This is how you have to solve. And the second question, this is a 3 by 3 matrix, 3 rows and 3 column. So here I have not written all the steps. You have to refer the previous problem and write the steps accordingly. I have written only the answer for P, Q and the formula of that. So P is half of A plus A dash. So here is the answer. You can see on the screen. This is the answer for P. And similarly, answer for Q. You got this matrix. 0 minus 1 by 2 minus 5 by 2, 1 by 2, 0, 3, 5 by 2 minus 3, 0 as Q. Then you have to add this matrix and this matrix. It can be, I have written in P by Q form, or you can write as a decimal form also. Okay. And you have to add these two matrices and check whether the answer what you are getting is question itself. Similarly, there is a homework question. All these are homework question. Similarly, you have to write for the third question. 1, 5 minus 1 and 2. You have to write this question's answer as sum of symmetric and skew symmetric matrix. So this is what is covered in this today's class. I hope everything is clear. I'm a bit faster in today's class because you already know how to add a matrix, how to subtract a matrix, and how to multiply a matrix. With practice only, it will be proper. The multiplication process, only by hearting or just going through the question, it won't work out. You have to practice. You have so many exercise questions, so many example questions in a textbook. Please try to do that questions, and if you have any doubt, please ask. I'll be very much happy to help you people. So you have to write the notes by yourself watching this video. And regarding an exam, I had gone through the papers. I think most of them have copied the answer, and it is like one have written the answer just blindly copied, and I think you have put it on the group and did all those steps. So I just gave you important question, and you people not even bothered to go through that question. I had changed the question, the values in the question, so that you can write it by your own. But still, you people just copied blindly and wrote what the other people have written. Simply lost marks here and there. I had told you, while solving the binary operation, you just give the numbers and then solve for commutative, associative, and what you people did, you just blindly written what is there in the answer, which I have given you, A, B, C, D, E, F. I think most of you don't know how to solve that also. Only few, I think few solved giving the numbers. Not few, very one or two people, only so much. So please be thorough with the topic. Don't just copy paste blindly. If you don't know any of the step, or if you find any difficulty in following my class, please do let me know about it. So in this chapter, the last topic is elementary operation. That is very important topic, and it's bit tricky questions will be there from that topic. So I thought I'll take it in the next class. So there are some steps regarding how to solve the questions. So by that topic, this chapter will be over. And yeah, only so much for today. Hope you all write the notes on time and submit. Write proper notes. Don't just write what I have scribbled in the screen. Okay, write accordingly. I want all these steps properly written. Write the notes neatly. And okay, thank you for listening and watching my class. That's all for today. Thank you so much, children.